light was first illustrated through different experiments on interference and diffraction.
Like all electromagnetic waves, light can travel through a vacuum. The transverse nature of light can be demonstrated through polarization. Just what is the true nature of light?
Is it a wave, or perhaps a flow of extremely small particles?
These questions have long puzzled scientists.
Let's dig in deeper to the two mostly compared attributes when it comes to light.
So then again,
is light a wave or a particle?
Light is a wave!
Light is a particle.
In the year 1665, an Italian physicist, Francesco Maria Grimaldi, discovered the phenomenon of light diffraction and pointed out that it resembles to the behavior of waves.
Known for his law of universal gravitation, English physicist Sir Isaac Newton realized that light had frequency-like particles when he used a prism to split sunlight from its component colors. Nevertheless, he thought that light was a particle because of the periphery of the shadows it created was extremely sharp and clear. Is that enough evidence for you to prove that light is a wave?
Yes, how about yours?
Well then, let's see.
Light can be described as an electromagnetic wave. In this model, a changing electric field creates a changing magnetic field. This changing magnetic field then creates a changing electric field. And boom, you have light. Unlike many other waves, light does not need a medium to wave in. I will be describing some of the behaviors of light as a wave, including reflection, refraction, and diffraction. For reflection, when a wave strikes a new medium, some of the wave will bounce off the surface. How reflective the surface is will determine how much light will be reflected and how much will be absorbed or transmitted. When light moves from one medium to another medium, it will change directions. This is a wave-like behavior, and it is called refraction. Another wave-like property of light is diffraction. When light waves encounter an obstacle or pass through an opening, they will bend.
Light behaves mainly like a wave, but it can also be considered to consist of tiny packages of energy called photons. Photons carry a fixed amount of energy but have no mass. The energy of a photon depends on its wavelength. Longer wavelength photons have less energy, and shorter wavelength photons have more. Red photons, for example, have less energy than blue ones. In physics, a photon is a bundle of electromagnetic energy. It is the basic unit that makes up all light. Also, it is called the quantum of electromagnetic energy. No, what you said weren't even enough to prove that light is a wave.
No, yours wasn't sufficient enough.
Hey,
Stop!
Huh?
You're both correct. Light is both a wave and a particle.
Okay.